So today I'll be talking about the smart meter and the related issues. And I will also give some background about the smart meter, because we were working from 2000 onwards. The smart meter concept and all such thing way back in 2000 itself started. But that time the people were trying to make something like good things out of energy meter. Something like they want to take automatic meter reading so that you don't spend a lot of manpower in going to the place and taking the reading. And also they try to interpret such a way that to detect a tamper and all such things. So it is a kind of automating the things. That was the only thing they were in mind. So they were doing that. That was called automatic meter reading. Therefore that whatever communication available during those time, they were trying to encash on this, whether it is a bit of wireless or RF or even power line communications. So it was going on. Then the concept of smart grid came into picture, because that has a lots of impact on the environment, carbon emission and global warming. These are all realities. And the thing is that, and the electrical industry, electrical, utilities, major cause for pollution in the atmosphere, excepting United States. In all other country, the number one, the culprit for atmospheric pollution is a thermal power station, which we use it basically for power generation. But America, it is a transportation which is slightly have an edge over thermal station. Otherwise, thermal station was also a major contributor for the things. But overall, all over the world, this is identified as a major, cause for air pollution. This atmospheric degradation. So they are trying to put cap on thermal generation electricity using coal. That's a major things. But it boiled down such a way that now how do we make a substitute? Because in the energy deficiency country like India, if you remove thermal station, then we are nowhere. That is the stage we are now. So it is unthinkable that we'll all of a sudden remove that. There was no alternative. So friends, then this photovoltaic, the efficiency started increasing. Maybe 5% to 10%, something like that. So what happened? Then generation by photovoltaic is much easier. Of course, wind is a very steady thing. It's not available everywhere. So it is not that easily we can do that. So these are all the things, which made. But the thing is, challenge is that then that efficiency started increasing our solar panels. So it became feasible. 18 rupees one time it was rated, and slowly it has come down. Now it is below 2 rupees. It is unthinkable and it is unimaginable. So we can generate now. Now when even the efficiency, the current of 21.5% goes up, then friends, generating electricity using solar become infinite. It is available, abundant available in our country. So we can easily depend. But only thing is that how do you, in a daytime it's all right, in night time it is not possible. So what do you do? So daytime generator excess, where do you store it? So these are all another challenge. So of course, in the horizon, people are trying to make use of pump storage systems and the chemical batteries to see that daytime you use them. So finally, what happened? There is a pressure on electricity producing company that you should produce Now, neat power, that is green power, this should be a part of this one. That's what you mentioned about. We keep hearing CAP 25, CAP 26 like that. And India has also become a kind of things at 2070 will have complete renewables. So many countries have gone ahead. That is 2030 they will have 50%. Now they say 60, 70%. Somebody said 2040 they will have full this one like this. So friends, this is the major thrust. So in that condition, how do you optimally utilize your energy? And how do you make use of that energy? By demand participation. So these are all driven, that it is this also one of the building block. We will come back. What is that smart grid like that? See, one of the building block. So one of the building block is advanced metering infrastructure. In that one, meter is a major, very important things, because till that time, it was not that intelligent. Okay, we made electromechanical to, electronic meter, but the sufficient intelligence were not available. So we migrated to putting lots of intelligence on the meter, so that it with this tariff revision, with various tariff and various stakeholder to access the data. So the meter has to become smart. So that is where the meter has to be smart to give the required information only to selected people with security. So these are all possible with this advanced microprocessor and communication systems, and connect and disconnect, so that now you don't really go to the customer's place to connect or disconnect. So friends, so this is a part of your smart grid. Kindly understand the smart meter is one of the building block in AI. AIMA is an important thing. And AIMA itself, advanced metering infrastructure itself, a part of building block of the smart grid framework. So with this one, we go to that. So let us see how we see about the history of these the meters. It's very interesting. Just to understand the basic things like this. So when this in the recent years, domestic industries have shifted from traditional meters to smart meters. This is a reality. And it were electromechanical were dominant in 1970s, and 1990s, 2000, the electronics came into picture. That time now the power grid also started increasing. Then but it is only one-way communication. So it was not two-way not possible. So that was the limitation. Then became this smart meter. And that is the status of state of art of that things like that. Now let us go back to history to just remember the people who developed the electricity and how they started measuring it, like that the coulombs, voltas, Michael Faraday, Maxwell, they all contributed to the development of this electricity. And really, in the real breakthrough was 1879. Thomas Alva Edison invented electric bulb. It is only for light. The battery delivered DC directly to the user facility, and the battery delivered by delivery wagon, the Hooligan model. That was a system that time. They made it. And the very important person is that in this electricity is especially alternating current, these things, this Nikola Tesla. We should remember him for his path-breaking, discovery, all such things. This has done like that. And addition, and there was a war of currents between AC and DC. Finally, that Westinghouse became the benefited of getting his Tesla's work. And of course, that central things like that. The same thing. But thing is that how do you measure? Say it became commercial. So how do you measure it? That became a task. So they used chemical electrolytic meters or exclusively ampere hour meters. So they started seeing the weight of the cell plates. That was the measure. Ampere hour meter, then register meter. Then finally came these induction meters. You'll be, and from there, the Tesla added to identify concept rotating magnet. He is a inventor. Then for a proven torque could be produced electromechanical by two alternating current fluxes. So they people have developed. With this one, disk induction motor principle awarded priority. This was just one Tesla's many patent later purchased by George Westinghouse. So this is a concept. Two coils, and with that one magnetic field coil generates. From second coil, interact disk accelerated without bound except for eddy currents caused by motion through fixed. So end result is the evolution of the disk measures the constant amount of energy. So this has happened. And there are all people, induction watt-hour meter. These are all history just to understand that how they invented electricity, and when they make the commercial, how did they start measuring it? This Thomas Duncan developed first induction watt-hour meter to use single disc for both the driving and braking elements. At this time, AC has now become used for run motors, existing ampere hour meters, and commutator type. Several inventors worked to develop new meter to meet these needs. And Schellenberger hit on the most workable approach, a small induction motor with a voltage and current coil 90-degree out of phase with each other. So the first meter, you can see that it was weighing 41 pounds. And it was most.
Hello.
Yes.
Sir, a screen is not visible on my screen.
Okay,
PPT.
now it's visible.
PPT is not showing on my screen.
Is it the case with everybody? Friends, can you give a feedback? Can you able to see my presentation?
Yes, sir.
I think you kindly check up your internet. No, that may be sometime problem. So then Blondel's theorem, just we have to remember him. The polyphase watt-hour meter was the first set forth on scientific basis 1893 by Blondel. His theorem applies to measurement of real power in a polyphase system of in any number of wires. If energy is supplied to any system of conductor through n wires, the total power in the system is given by the algebraic sum of the readings of n watt meters, so arranged that each n wires contain one current coil, the corresponding voltage coil being connected between that wire and some common point. If this common point is one of the n wire, the measurement may be the use of n-1 wattmeter methods. This is what we use it. So these are all the developments. In that one, overload temperature compensation, standardized circuits, laminated disc, magnetic suspension, magnetic suspension bearing. So these are all the development over a period of time. And the 1970s saw the introduction of electronics, first into registers and later for metrology. So friends, this is about the discovery of electricity and things like that from various scientists. What is their contribution from Coulomb to Maxwell, and the incandescent lamp developed by Thomas Alva Edison. Then came this Nikola Tesla. He is a major contributor for the rotating, magnetic field. And there was a war of current between Thomas Alva Edison and Nikola Tesla. Nikola Tesla is a proponent of AC, and Thomas Alva Edison proponent of DC. But finally, Westinghouse took all his patent, and they developed lots of products. So the Westinghouse became the benefactor. He benefited through the invention of Nikola Tesla. And electricity. So when the electricity was developed and the bulb was invented, then how do you measure it? That is the next change. First time they put light, number of light burning, number of bulbs. That was a thing. Then next is that they went to next is that clock, and then they went to electrolytic meters, or actually ampere hour meters. Chemical cell measure the electricity by change of weight of cell plates. You see, this is the way they were measuring that. Then became the induction meters, and like that. Here we mentioned about Nikola Tesla, and so this is where you can see that it was weighing about 41 pounds, around 20 kg. So finally it has come to the induction meters. Then this is what, 41 pounds. Then slowly they went to this one, and this is a Blondel theorems. In a sum of single phase measurement, add it, so it gives a total power. This is simple principle. And over a period of time, 1920s, 34, 30s, 48, all such, they added many things into the meter. And finally, the electronics started emerging in 50s. And one best thing about electricity is that we were embracing this development, whether it's electronics or communication, to our systems. So we saw that introduction of electronics, and the whole thing was replaced in 2006 completely. Many people stopped developing electromechanical meters from 2006 onwards.